We're looking at algebraic fractions, and there are three main subtopics to this. There is simplifying fractions, timesing and dividing fractions, and adding and minusing fractions. So let's first look at simplifying fractions. A very, very simple version of this could be something like, 25 over 5x. What we can see here is we've got a common factor of 5 in both cases. And so I can divide the top and the bottom by 5. And what I end up with is going to be 25 over 5 gives me 5. 5 divided by 5 gives me 1, so it's just 1x. And so, that's a very simple example of simplifying. In general, it's a bit more complex, right? We often end up having to deal with quadratics like this. But it's the same principle. We just want to find a common factor in the top and the bottom and then divide by that factor. And so in this case, if I want to find a common factor, well, the key is factor, right? What do I want to do when I want to find a factor is I have to factorize. And so I'm going to factorize this top bit, this numerator. So, what I need to do is I'm going to have my standard factorized format. I've got to find two numbers that can times together to get 6 and add together to get 5. Well, that's just going to be plus 3 and plus 2. And my denominator stays the same. What we see is that we can therefore cancel that common factor, just like we did when we divided the top and the bottom by 5, and we cancelled 5 from the top and the bottom. And our final answer is going to be just x plus 2. An exam little trick that I often teach is that, when we're given something like this in an exam, we know we're going to probably be cancelling out some factor from the top and the bottom. And so I know that I'm most likely going to have an x plus 3 bracket on top, because I know that I'm eventually going to probably cancel that x plus 3 with the bottom x plus 3. So I could just start off by filling in x plus 3 in that first bracket to save myself some time. Right, let's go on to timesing and dividing. So timesing is very nice. We'll cover dividing in a second. If I'm timesing fractions together, it's just top times top, bottom times bottom. And so I end up with x squared times 7, I get 7x squared, and 5 times x, I get 5x. And I could simplify this further. I've got a common factor in the top and the bottom, just like we had again with our simple example. In this case, I've got a common factor of x, and so I can cancel out x from the top and the bottom. So I'm just left with x on the top rather than x squared, and I'm left with 5 on the bottom because again I've cancelled out that x. And that's our answer. That's our final answer. Right, moving on to the final subtopic, adding and minusing. So this is slightly trickier. Counterintuitively, it takes a bit longer to do this. What we need when we're minusing fractions, just like with regular fractions, we need a common denominator. And there's a trick that we can use. We can basically use these two existing denominators to turn this problem into a nicer problem. So I'm going to take this whole fraction, and I'm going to times it by that denominator. I'm going to take this whole fraction and times it by that denominator. And you'll see why in a second. When I do the first fraction times x, I end up with x cubed over 5x. And I take the second whole fraction, I times it by this denominator, by 5, and I end up with 5 times 7 to get 35 over 5 times x to get 5x. And you can see right now that the trick's worked, right? We've ended up with the same denominator in both fractions. And so this can then be combined, right? We can just combine the numerators together now, and I end up with x cubed minus 35 over 5x. And that is our final answer. Right, let's go on to some practice exam-style questions and put into practice what we've just learned. So yeah, we're going to first tackle a simplified question. So in this case, again, I can see I'm probably going to have to find a common factor in the top and the bottom. So I'm probably going to have to factorize the bottom. And I've therefore got to think of, I'm going to have my standard format for factorizing. It's going to be that standard format there. And I've got to think of two numbers that can times together to get minus 16. And I'm actually going to rewrite this as x squared plus 0x minus 16, because we can add in a 0x if we want to. And so I know my two numbers here and here have to add together to get 0. Well, these two numbers are going to have to be 4 and minus 4, right? Minus 4 times 4 gives me minus 16. 4 minus 4 gives me 0. So that's going to be my factorized format. And again, we could have cheated and used the fact that I knew I probably needed an x plus 4 term in here, right? Because I know I'm probably going to be cancelling out a common factor. What we end up with is x minus 4 in our denominator. Right, moving on to dividing next. So just before we do any dividing, I'm actually going to want to simplify this slightly and turn it into a timesing question. And just to look at a much nicer example, I can either do kind of a quarter of 20, and I can get 5, or I can do 20 divided by 4 and get 5. And I can actually take this 4 and I can divide it by 1. I'm not changing anything, but I'm just writing it in a different way. And what we see here is I can either divide by 4 over 1, or I can times by the flip or the reciprocal of that fraction, right? I can flip the top and the bottom and turn it into a times question instead. So I'm going to do that here. I'm going to turn this question into a times question. So it's going to be times x squared minus 4x over 2x squared plus 9x plus 10. So I've just flipped the top and the bottom and put a times in instead of a divide. And we're now going to factorize everything, as we always do in this case. Well, I'm going to look at the first fraction. Can I factorize this at all? I've got a common factor of 3 in these two terms. So that numerator can probably be factorized. I can pull out a 3 and write this as x plus 2. In our denominator, I can't do anything with that. That's just going to be our standard x minus 4. And with the second fraction, again, I've got a common factor in these two terms. So I can pull out x. I'm going to be left with x minus 4 in the brackets. And I've got a standard quadratic on the bottom. I'll hopefully be able to factorize that as well. Again, I'm going to be dealing with 2x plus or minus something and x plus or minus something, right? Because I know I need to have that 2x squared term. So I've got to have a 2x here and an x here. And we can use our cheat here, right? I know that I've got to find two numbers that times together to get 10. So it's probably going to be 1 and 10 or 2 and 5. Well, I know I've got an x plus 2 here, right? So my first guess is going to be that I'm probably going to have an x plus 2 bracket here. I'm also going to have the two numbers, I'm going to times this 2 by 2 and then add it on to this number here to get the coefficient in front of x, right? So I'm going to end up with 4x plus something x should give me 9x. Well, I know that something has to be 5, sorry. And it all, works out because I can double check, does 2 times 5 give me 10? Yes, it does. So I know that's going to be my factorized format. And I can now start cancelling some stuff, right? I've got x minus 4, x minus 4. I've got x plus 2, x plus 2. And so I end up with just top times top, bottom times bottom. I end up with 3x on the top, and I end up with just 1 times 2x plus 5 on the bottom. And that's my final answer. Right, one more to finish off. Let's finish off with an adding question. So I've got to solve for x, but I first of all got to take care of this left-hand side. I've got to add these two fractions together. So we'll do our standard trick. I'm going to take the whole first fraction and times it by the second denominator. So I'm going to times it by x plus 7 on the top and the bottom. And I'm going to take the second fraction and times it by this first denominator. So that's going to give me 3 brackets 5 minus x all over, again, 5 minus x times the original denominator of x plus 7. And what we can see here is, I've now turned this into a much nicer question, right? I've got the same denominator in both cases. I just realized that's a times there. I want to put a plus sign there. And now what I need to do is I just add these two fractions together. I just add the two numerators together. And so I get 2x plus 7 plus 3, 5 minus x, all over 5 minus x, brackets, x plus 7. Well, I'm solving for x, right? So, I want to simplify this down as much as I can, and I don't want to have any x's in the denominator. So I'm going to times both sides by the denominator to get this whole thing out of the denominator, first of all. So I get just the numerator left where it is. And obviously 1 times this denominator is just going to be that same denominator. And what's next? Well, we probably want to expand out everything now, because I want to eventually get all of my x's onto one side. And so if I expand this out, I get 2x, and then I get minus 3x, so I get minus x. And I've got 2 times 7 is 14, plus 3 times 5 plus 15. 14 plus 15 is going to give me positive 29. So that's my left-hand side. My right-hand side, I'm going to end up with minus x times x, so minus x squared. I'm going to get x times 5 to get plus 5x. I've got minus x times 7 to get minus 7x. And I've got 5 times 7 to get plus 35. Well, 25, 35. When I know that, 5x minus 7x is just minus 2x. And, I generally want to have a positive x squared. It's quite tricky to solve quadratics when I've got a negative x squared. So I'm going to actually get everything on the right-hand side, and I'm going to bring it over onto the left-hand side. So I'm going to add x squared to both sides. That's going to give me x squared there. I'm going to add 2x to both sides to take care of these two terms. So I've got minus x plus 2x to get plus x. And I'm going to minus 15 from both sides. So 29 minus 15 is going to give me minus 6. And I'm left with nothing on the right-hand side. I've cancelled out all those 4 terms now. Well, now we're just solving a basic quadratic, right? So hopefully we can factorize this. I'll put this into my standard factorized format. And if we look at how we can solve this, I need to find 2 numbers that times together to get minus 6, adds together to get 1. That's going to be plus 3 and minus 2. And so x, therefore, to make this whole thing 0, well, if this bracket's going to be 0, x has to be minus 3. If this bracket's going to be 0, x has to be 2. And that's the end of algebraic fractions.